Effect of high-frequency near-infrared diode laser irradiation on periodontal tissues during experimental tooth movement in rats. Background and objectives. Tooth movement during orthodontic treatment is associated with bone neoplasticity and bone resorption on the tension and pressure sides. Previous clinical studies have suggested that low-power laser irradiation can accelerate tooth movement during orthodontic treatment, although the underlying mechanism remains unclear. In this study, we used a high-frequency near-infrared diode laser that generates less heat and examined the histologic changes in periodontal tissue during experimental tooth movement with laser irradiation. Methods. A nickel titanium closed coil was mounted between the maxillary left side first molar and incisor of rats to model experimental tooth movement. The laser irradiation and the control groups were set, and the amount of movement of the first molar on 7th and 14th days after the start of pulling of the first molar tooth on the maxillary left was measured by three-dimensional analysis of micro-CT. After tooth movement, tissue samples from the mesial and tension sides were collected, and successive horizontal sections were prepared and examined using hematoxyliniacin and trap staining and immunohistochemical staining for ANKL, OPG, ALP, and proliferating cell nuclear antigen, PCNA. Changes in tissue temperature following laser irradiation were also examined. Results. Laser irradiation significantly increased tooth movement compared with non-irradiated controls. Histologic staining of the pressure side mesial root in laser-irradiated rats revealed enhanced Rankel expression and increased numbers of trap-positive cells compared with controls. By contrast, on the tension side, laser irradiation led to increased expression of ALP and PCNA. These data indicate that high-frequency near-infrared diode laser irradiation on the pressure side upregulates Rankel expression and accelerates osteoclast differentiation, facilitating bone resorption, whereas bone formation is induced on the tension side. Conclusion. This study demonstrates that high-frequency near-infrared diode laser irradiation of periodontal tissue leads to metabolic activation, which ultimately increases the rate of tooth movement. Lasers Surg. Med. Copyright 2018 Wiley Periodicals Incorporated.